Yeah, my name is Stefan Bartscher, and I'm working for innovation management for production in BMW. We're working for the manufacturing of the future. So how could the plant of the future look like, the automotive industry of the future look like? At this project we are focusing on robotics. And robotics, the MIT is one of the hotspots in the world, or better to say, the hotspot in the world. Yeah, that's why I'm here.
My name is Shah. I'm an assistant professor in the Department of Aeronautics and Astronautics, and I lead the Interactive Robotics Group as a part of the Computer Science and Artificial Intelligence Laboratory. And my area of expertise is human-robot interaction. My lab focuses specifically on integrating robots to work in teams with people in what I call high-intensity and safety-critical applications. So a lot of our ongoing work is in the area of manufacturing and assembly, how you strategically integrate a robot to improve the efficiency of manual work, manual processes today. Our project is to improve the efficiency of manual final assembly of cars through the introduction of robots to work with people through human-robot collaboration. And on the factory floor today, there's people putting the cars together, but they walk back and forth from the carts to pick up the tools and materials they need to build the car. And that walking time is non-value added work. And so the concept here is to put a mobile robotic assistant on the final assembly line to do these elements of bringing the tools and materials back and forth to help support the people at being more efficient at their work. The timeline is about a 3-year project. We're almost a year into the project now, and the goal is by the end of the project to have a working prototype to try out in the factory.
In the beginning, Julie met us in Munich in order to really pick up on the details of the project and to understand our manufacturing specialities in one of our plants, like in Munich. And then step by step, we said, like, okay, it makes sense that the teams collaborate closer together, and so we have a video conference every second week, really on technical details. And when it makes sense and a major step or goal is close by, we meet in person here in the lab, or the teams will meet and really like working concentrated and focus on specific topics. Yeah, we have in our lab, we already have some hardware, so we have a mobile robot in our lab in Munich already. And just last week, the hardware arrived here at the MIT, and they already did a perfect job on theoretical background and all the mathematics and control algorithms in order to solve some of the challenges in moving on and off a moving assembly line.
The initial challenge is one of the basic capabilities we need in place to make a useful system is the robot needs to navigate on and off a moving line. So part of the ground is fixed, that's how we're used to driving robots, but on the assembly line, part of the ground is also moving. And so it's a tight space, so sometimes the robot needs to straddle that moving line, be completely on it, cross it. And so we've been working on developing the control capability, layering over the navigation so that it can move and work in that confined space. And so we are we received the robot just on Friday, so we have much of these algorithms working in simulation, and our summer project is to translate that to the hardware system. It's really helpful and exciting that the same robot technology is in Stefan's lab too. He's had the hardware for a while now, and so that makes a nice collaboration where we have equivalent hardware kind of in both countries to work with and to share software.
We have expertise here in Julie's group on the mathematical side, and my team knows much better the reality in production, in the real production world. And so it's kind of natural collaboration that yeah, each group knows where its specialties are and what they should focus on. And due to this permanent contact at least every second week, we do it like from step by step, like from week to week. We know where to focus on and what to do in detail.
Generally, about the research collaboration, it's you know, really extraordinarily exciting to be working in close collaboration with the people who make this happen on the factory floor, and you know, we rely on them to help us understand what are the needs of the application and how is it we guide our research to solve, you know, a practical real-world problem. But there are many kind of fundamental research challenges along the way, which makes it you know, an interesting give and take. Like any research application, we have our milestones, we know what we want to achieve at the end, and then every other week we get together and we lay out where we are, and we make plans forward. And you know, it's a incredibly exciting opportunity for us here at MIT. Concrete next steps are to make this robot exercise on the treadmill in C-Sail. It's going to be running up and down and on and off the treadmill, and once we've shifted the algorithms from simulation to hardware, we'll be ready to do a transfer of that technology to you guys to be able to do testing in your laboratory and eventually on the factory floor as well.
Yeah, actually, step by step, coming closer to the real world then, from simulation where we are now, to implement the algorithms in the mobile robots, step by step increasing the safety and possibilities and capabilities of these robots, and then hopefully in 2.5 or in 1.5, 2 years, we're going to have a running prototype which we can test in the real world on our manufacturing lines. And it's, I mean, we make it step by step, so we don't have a perfectly designed timeline. No, it's just like, okay, let's see, if that doesn't work, we have some other options, and it's the final goal which counts, not the way to the goal. Interesting will be when we have the prototype, how long it will take to really industrialize it and to make it open to a kind of mass market, if you can say so. In general, it takes quite some years from idea to transfer, and then also if you have transferred the first technologies, it takes usually a few more years before it's really picked up and understood in general and really transferred on a large amount or in a large level. And but I get the impression that these cycles get shorter, so industry picks up quicker and see the benefits, and yeah, let's make this beneficial for both sides, for academia as well as for industry. And finally, as I've focused on, is to make it an ergonomic workspace for the humans on the long term.